Good morning, everybody. Today we're going to be looking at all these probability questions and the way they've been asked on the Regents exam. So they definitely are going to make you take all of your lessons and have them with you. Make sure you have your formulas clearly, like maybe highlight them on each lesson so that when you're doing this review and tomorrow's review, you'll be able to find things easily. And then I'm going to only give you work again today and tomorrow, and then I'm going to open the test Thursday. That's going to give you Thursday, Friday, Saturday, and Sunday for the test in case you have AP exams. This way you can fit the test in, but when you take the test, guys, you must have all your notes out in front of you. And take your time, look everything up, and give yourself your best shot at success. All right. Let's take a look at number one. This one was from the June 2017 Regents exam. Data collected about jogging from students with two older siblings are shown in the table below. So here's the two-way table. Now we're talking about student who jogs and student who do not jog. So if you don't jog and you have siblings that don't jog, and you have only one sibling that jog, or both your siblings jog. And again, for people who do jog, and then again, going across the board. So these, with problems like this, we definitely are going to be looking at conditionals. Using the data to determine whether a student with older siblings is more likely to jog if one sibling jogs or if both jog. This is actually two different conditionals, and it's two different conditionals because of this little word here, or. Now, guys, this is why you got to take your time. So if I were to write out what's going on, because it says justify your answer, the first thing I have to pay attention to is that I am looking for the probability that a student jogs given one sibling jogs. So the given here is that one sibling is jogging. So if I were to write this now as a probability in terms of fraction, the bottom is going to be the number of one sibling jogging. And the top is going to be the overlap that the student does jog and what they have one sibling that jogs. And that now, ladies and gentlemen, comes from up here. I want the student jogging and I want one sibling jogging, and here is my overlap. This is my and. So the top up here is going to be the number of the student jogs and let me just find my little symbols here because it's really difficult to do the typing on here. There we go. And one sibling jogs. So if I can do this, if I can find these numbers from the table, then I can do this conditional. And I know it's not like the neatest typing, but at least you can read it. There we go. So this now is going to become the 416 over the number of siblings that jog. Now here's where I have to actually add up the 18, 23, and the 416, and the total for this column here is 2,239. And that now becomes the bottom of my fraction. And so therefore, since that fraction doesn't have a whole lot of meaning to me because it's just the numbers are too big, I'm going to approximate to about 3 decimal places. So I'm going to say this is equal to 0.186, or roughly 18.6% of students will jog given the condition that one sibling jogs. Now the next one would be, what's the probability that a student's going to jog if both their siblings jog? So then it almost becomes like a family thing. So at the risk of taking all the time to type again, I'm going to, just start cloning things so I can go a little faster. So now I want the probability that a student jogs given both their siblings jog. So now this guy here is going to be, and I need this, my overlap. And so now what I need to do is I need to add up both siblings jog, and the total that both siblings jog is 1,780. So this now is going to become 400 because the overlap on this one, let me again show the overlap, I'll use green. The student is going to jog and both siblings jog. That's my overlap, that's my top now. And my bottom is the 1780. So again, my top is 400 and my bottom is the 1780. However, this, again, fraction isn't going to mean much to me because if the numbers are big, but if I divide, I get 0.225, or pretty close to 23% probability that if two of your siblings jog, you're probably going to jog too. And so then the overall question, the answer now, because so often people spend so much time on the work, and yes, this work is pretty significant, but if you don't put the time into making sure you literally answered the question, you get hit hard on a Regents, which of course you guys are all lucky that you're not taking, but you are going to move on. So we'll just pretend that you're taking it. So the bottom line is you would have to then make sure you write an answer that says, more likely to jog, a student is more likely to jog if both siblings jog. And there you go. So that would be number 1. So number 2 is all about the Venn diagram, and I think I'll do number 2 with you because there's a similar one on number 7, so we'll have you do number 7 without me. let's take a look at number 2. A suburban high school has a population of 1,376 students, and some participate in sports and some participate in the band. And so the bottom line is we have a Venn diagram. So you know what? I'm going to cheat a little bit. I'm going to try to make my Venn diagram this way. And hopefully I'll be able to make it so that I can just see if I can make this bigger. There we go. All right. So not the best, but at least you'll be able to read it. All right. So first thing, our total. We have 1,376 students in this school. Now, the next thing we know is that some of the students participate in sports, and some participate in music. And then this is my overlap of sports and music. So I'm just going to write S. And you know what? Let me see if they have this symbol up here. Let's keep our fingers crossed. There we go. Hooray. Okay. And music. So there's my overlap. Now, the next thing is we have to see what's going on with this. The number of students who participate in the sport is 649. So if I have sports, and then I have the number of students who participate in music is 433. And the probability now that a student participates in sports, or this isn't an and, now they're giving me an or, which is really significant. So now the probability that a student participates in sports or in music, let me get to my or music, is equal to the probability of sports plus the probability of music minus the probability of sports and music, the overlap. So I need my little overlap symbol. Oops. All right, sports and music. So here's the formula from way, way back when we began this. So let's write some things in. The first is they tell me, excuse me, that the probability that a student participates in either sports or music is 974 out of 1,376. I'm going to actually try to write this now. So now I have 974 rather, excuse me. And the 1,376. And this is going to equal the sports, 649 out of 1376. Plus the probability in music, 433. out of 1376 minus now the overlap, which was what we don't know. We don't know the overlap. So now this is going to be the and statement, the probability of sports and music Now, the thing is, all my denominators are the same. So since all my denominators are the same, what I'm going to do is I'm going to drop the denominators, just like we would have done when we did the fraction unit. And let's just take a look at this in terms of the numbers. If I have 974 is equal to 1,082, because if I add 649 and 433, and then I say minus, and I'm only going to use the number now, the top, the numerator, the number of sports and music, then this becomes a little equation to solve. First and foremost, if I don't want to have a negative number of sports and music, then I can move this to the other side. It becomes positive, the number of sports and music. And then what I would do is I would have my 1082, and I would subtract from that the 974. So what this does is this will tell me now that the overlap was 108. So if I now write it as the probability, my answer now is going to be the probability of sports and music is now equal to 108 out of 1376. Again, you don't have to reduce, and they're not asking you to analyze this. I mean, if they were going to ask you to analyze what we think it means, then, maybe you would turn it into a decimal so you could think about it in terms of percents, and that makes life easier. But right now, this is what you would have. You then could fill in your Venn diagram, but we find out that we really don't have to, but if you did, because that could be a question, let's just say here would be the 108. And then you would have to take your number of sports, your 649, and subtract 108, and you would have 541 are just in sports. And then you would have to take your music, your 433, and subtract your 108, and have 325 just in music. So then if we add up the 325, the 108, and the 541, and subtract that from our 1376, we find that we have 402 are doing neither. And if we had to make a Venn diagram, they didn't ask us to, but I might as well review it. This would be my neither. There we go. So hopefully that one went well for you. Now, number 3. Now notice these are pretty big problems. These are definitely on the part 3 or part 4. A student is chosen at random from a student body at a given high school. The probability that the student selects history as a favorite subject is 0.35, which is pretty significant. And the probability that the student chosen is a senior is 0.55. So one of the things that I would absolutely do if I were the student taking the test, and actually as the teacher grading the test, is I would make a list of my important items. So the probability that the person that is picked likes history, I'm going to use H for history, is 0.35. Then they tell me the probability that I'm talking about a senior is 0.55. Now, the probability that the student chosen, the student selected is a senior, or that the student chooses history as the favorite subject is 0.70. So that's pretty significant. Let's write that out. The probability that the person chosen is a senior, or, now that would be that big formula we just did, a senior or they like history as a favorite subject, is now 0.7. So if they want me to say what is the exact probability that the student selected is a senior whose favorite subject is history, I have to find the and. I have to find the overlap. I don't have a choice. So I'm going back to that formula. So again, I'm just going to write down the probability that the person selected is a senior and their favorite subject is history. I have to find. So let's go over here and let's start with that formula from the other page, which is my or. So the probability of being a senior or history is going to equal, let me just move this out of my way, it's going to equal the probability of being a senior plus the probability of history minus the probability of being a senior and history. So I need that overlap. Okay, so I know my or statement is 0.70. I know the probability of a senior is 0.35. And I know, whoops, I'm sorry, senior was 0.55. And history, rather, was 0.35. And now I have to have the probability of the senior and history. So I got to do the math on this. I'm going to move my minus to the other side to make it positive. Probability of senior and history. And if I add up the 0.55 and the 0.35, I have 0.90. I'm going to now subtract my 0.70 from both sides. And here my overlap is 0.20. Now I needed this because now the question that they're asking me to solve is actually a conditional statement. Let me just move this out of the way. Because I say, what is the exact probability that a student selected as a senior whose favorite subject is history? Now, the condition is that you're a senior, and then I want history to be your favorite subject. So this now, the question they're asking me is to find the probability that you like history given you're a senior. And that now is going to come from the overlap history and senior, which is 0.20. And that is going to be over the probability that you're a senior. And if I were to divide this 0.20 by this 0.55, I am going to get the final answer for this part, which is 0.36 repeating. And since this is a repeating decimal, it sometimes is hard to understand the repeating decimal. You know, maybe now you would turn this back to a fraction, because the fraction in this case actually is a little bit easier. This fraction is 4/11. So 4 out of 11 seniors have history as their favorite subject, so that might be a little bit easier to follow. And this would now be your answer. They didn't ask you to explain it, so I would just do the math. So again, this looked like a small little question. It wasn't. You had to use your or so you can find the overlap, because the question was a conditional, and the condition is that you are a senior. And since this is the condition that has to go on the bottom, you had to have an overlap for the top. So the top had to be an overlap. You had to use the OR formula to successfully find the overlap, and then you can do the conditional. Let's take a look at the next part of the problem. The next part of the problem says, are the events a student is a senior and the student's favorite subject is history independent of each other? Well, if they are independent, we can either do this with multiplying probabilities or with the conditional. Now, if I take this with multiplying probabilities, because to me that one is the easiest one to do, so I am just going to label this would be, I would check to see, is the probability of being a senior multiplied by the probability of your favorite subject is history equal to the probability of being a senior and your favorite subject is history. So now I would have to see if my overlap works. Well, the probability of being a senior is 0.55. And the probability of liking history is 0.35. So if I were to type this into my calculator right now, I am going to get, for the left-hand side, 0.1925. Okay. However, over here, the probability of being a senior and liking history is 0.20. Now, a lot of times people would say, yeah, close enough. The problem is these aren't the same. When you're dealing with probability, unless you're told you're allowed to round, you're not allowed to round. And so you can't say 0.19 rounds to 0.2. This was very specific. You got 0.1925. And 0.1925, ladies and gentlemen, is not, and where is my not equal symbol? I know it's in here someplace. There it is. is not the same as 0.20. So your answer to this would be, since they are not, since the product of the individual is not the same as the overlap, these two are not independent. You could call them dependent, you could say therefore they're dependent, but right now they are not independent, and that is mathematically what you can prove. Now again, this is multiplying probabilities. If you decide that you like conditional to prove independence, then the formula for conditional probabilities to prove independence is you would need the probability that you're a senior and history, given you're a senior, would have to equal the probability that you liked history standing alone. So remember, when we said to prove independent with conditionals, you would have to actually equal the overlap, and the senior would have to equal the history standing alone. So the history, given you're a senior, we found out up here was 4 out of 11, 0.36 repeating. And so if I have my 0.36 repeating, is that the same as liking history? Liking history was 0.35. So 0.36 repeating is absolutely not the same as 0.35. Again, if you rounded and you were rounded without permission, you might say, yeah, they're the same, but you are not allowed to round without permission. So these are not the same, and you would have the same conclusion. I hope that that helped you out. It's tying everything together. So now I'm going to ask you to do your best on tying everything together. And if you're having trouble, please let me know. There are 13 problems in this little review packet, and I just went through 3, so that leaves you 10 problems for review. Take your time, and please contact me if you need help with anything.